Okay, so on your quiz and test that'll be coming up, you will have to be able to take a function like we talked about slope-intercept form, like y equals 3x plus 2, and make some predictions. You can use graphs, tables, things like that. I've discussed before with you that math is the study of patterns, and that's what this really is. And so let's talk about that real quick, this whole pattern idea. So the table below shows the relationship between the number of kites in an arrangement and the total number of ribbons on the kite's tail. Describe the pattern in the table. How many kites could you make with 275 ribbons, and explain? So one kite uses 5, right? So 2 uses 10. We're talking about the ribbons on the tails here. You can count them 1, 2, 3, 4, 5. 3 is 15. 20 is, or 4 kites is 20. So how many could you make with 275? Now, I would hope you all could say, okay, well, I would take the 275 divided by 5, right? Because there's 5 on each one, and that would give you an answer. So it's 5 per each one. Now, we practiced this part yesterday. Just want to hit it with one more time. Identify the solutions of two variable equations. So is 310 a solution of this equation? And again, remembering that the first number in the parentheses, right, in the ordered pair there, is the x. Second number is the y. So that means everywhere I see an x, I plug in the 3. Wherever I see a 10 or y, I plug in the 10. So we say 10 equals 4 times 3. So 10 equals 12. Well, that's not true. So no, 310 is not a solution of y equals 4x. Go ahead and head on to class kick. You've got a couple just like this. Using the exact same equation here, y equals 4x, we're going to try each of these and see if they work out. And you can see the answers down below here. So if you already have yours done, you can zip ahead if you got them right. If you didn't, go ahead and watch. So y equals 4x. So that means 20 equals 4 times 5. Well, that's true. 20 equals 20, so yes, this one works. Next one I've got is -5, -20. So -20 equals 4 times -5. That's also true. -20 does equal -20. So check, B works. C I'm going to do down here. We're going to try -5 equals 4 times -20. Well, that's not true. -5 does not equal -80, so no way. Then the last one here, it wants to know is 1.5 and the 6, so that ordered pair. So does 6 equal 4 times 1.5? That is true. You can check it if you don't believe me, but that is true. So yes, yes, no, yes. That's what you should have gotten on your class kick. Go ahead and continue watching for another example from me. Alrighty. Says here, use a table, an equation, and a graph. So ages, both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? So, again, it says, so some important information in here, right? It says that Kim was born 2 years before Carrie, right? So when Carrie was born, or when Carrie reached 1, Kim was 2 years older, right? 1 plus 2. When Carrie was 3, Kim was 5. 3 plus 2. You extend it all the way out here, right? Every time it's going to be whatever Carrie is plus 2. Gives you Kim's age. So here's a table. That's a pretty easy table to make, right? You could have started 0, 2 if you wanted to. When she was born, Kim was, Kim was 2 if you wanted to. And you keep going, right? If I put down 55, you'd say 57. Write an equation. Now, again, remember those let statements? We talked about this before. Let x equal Carrie's age. Let y equals Kim's age. From the table, can you see that y is always 2 greater than x? In other words, so Kim's age, which is going to be y, I'm going to write that up here so we remember that. We're going to say y and x. There we go. But we can see that it's always 2 more. right? Add 2. So add 2 and you get y. Add 2 and you get y. We can graph it. And again, we did talk about before how that actually technically starts out with the point 0, 2. Because when Carrie was born at 0 years, Kim was already 2. So that's that point right there, 0, 2. Notice there's no negatives on here. It doesn't make any sense. You can't have a time machine. You can't go back in time. They can unage, you know. So again, then we have the point 0, 3, the point 2, 4, the point 3, 5, so on and so forth. So again, notice we have a table, an equation, and a graph. That's what we're looking for. All those things. And you'll have homework just like this. In fact, today's will require you to do that. All right, go ahead and pause, head into Class Kick. Your turn. So here's the one you should be seeing in Class Kick. I've included the answer up here in the corner for you. So you can kind of see it, and I'll refer to that as we go here. Will runs 2 laps before Megan joins him on the track. So there's that 2 ahead again, right? Then they run together at the same pace. How can you represent the relationship between the number of laps Will runs and the number of laps Megan runs in different ways? It's a table, an equation, and a graph. Alrighty, so I'm going to get started with that. And we're going to have Megan's laps. We'll call those X, that's Megan. And we'll have Y will be Will's laps. And I like to make my tables this way, by the way. To make them, I'm a big fan of making them vertically as opposed to horizontally. Just better for the way I think. But anyway, we can actually start with the 0 thing. When she just starts running, he's already ran 2 laps. After her first lap, he is on his... Oh, it's 6 laps, not 2. I misread that. 6 laps. He is on... Hang on a second. Sorry about the confusion there. There we go. He has already ran 6. When she starts, so she comes cruising along, he's already run 6. She's run her first, he's run 7. She's run her second, right? You get the idea? He's run 8. And you can keep going. We can have 3, and again, add 6 is 9. And then her fourth one, add 6, and it's 10. So on and so forth. I think you get the idea there. So we've represented it now with a table. We want to represent it as a graph, same kind of thing. So Y, right, that's Will. I'm going to switch colors on this here. Y, or Will, equals Megan, that's X, plus the 6 laps. So this is the equation we should have written. And now we have to graph those same points. So we start out 0, 6, right here. Then we have 1, 7, right? And then we have 2, 8. And you just keep going, right? And it creates a... Now, again, technically this one, you could connect the dots. I don't know why you would, because if we're just counting the completed laps. But if we were to make a line out of it, it would obviously look like this, going up. Not going backwards, because you can't run 0 laps and undo them and that sort of thing. So, but again, taking a quick look here. Whoopsie, you have the wrong thing. There we go. This is what I want right here to show you. To get out of the way. Maybe I just move that out of the way. There we go. So again, the graph. Let's take a look at part B on that real quick together. Describe how the graph in problem 2 above would change if the difference in ages were 5 years instead of 2 years. That takes us back to the other one. The beginning point of the graph, so this takes us back to the example we did before. The beginning point of that graph would instead have been at 0, 5 instead of 0, 2 because it's 5 years older. That's the only difference that you would see. So go ahead and keep watching for another example from me. Alrighty, so continuing with that concept of a pattern, right? Looking for the pattern. So the table shows the relationship between the number of blue tiles. Notice the blue one in the middle, right? And the total number of tiles in each figure. Extend the pattern. What is the total number of tiles? Figure with 8 blue tiles. So we've got one figure has 9 tiles, right? 1 blue, 9 total. 2 blue, 18 total. 3 blue, 27 total. We can make a table, right? Just like we did. X is going to be the number of blue tiles. Y is the total number of tiles. And again, so if we go all the way out to 5 tiles, we had 45. Maybe you're kind of getting the pattern here, I'm hoping. It's times 9, right? So it's y equals 9x if we were to make our own equation for it. So I kind of went out of order here what they're doing, but draw a graph, right? So, well, 0, 0 technically, right? I suppose that does work. If you have no blue tiles, there's no other tiles either. So 1, and notice they're counting my 9s on the side here. Be careful of that on the quiz and test, by the way. And so 1, 9, 2, 18, 4, right? So on and so forth. This one would be tricky if you're trying to count the slope, by the way. They're trying to trick you here. Total number of tiles then. So if we extended that pattern all the way out, 8, technically times 9, is 72. 8 times 9 is 72. But again, you could do that with the graph. You drew the line. You could just, or extended the line rather, right, like this. You could go up and you could find that. Pause, go ahead and head into class kick. I've got a couple there for you. All right, we're going to break up A and B into 2 parts on this. Use the tile figure from problem 3, so I brought it along with us just to remind you. How many tiles in all will be in the figure with 24 orange tiles? So you got to start a different table here this time, right? This time I'm going to bring up my answer key for you here. This time, when I have 4 orange, I have 9 total. 8 orange, 18 total. 12 orange, 27 total. Getting the idea there? So no, that y isn't going to change. The 9, 18, 27, 36 isn't going to change. But the number of orange tiles, 1, 2, 3, 4, right? 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. I'm not asking you to write an equation on this one, just to figure out, okay, well, with how many tiles would there be with 24 orange tiles? So you'd have to extend this out, keep going, right? Keep going through pattern. You could, base it on the last one that we did, obviously. And again, the idea would be to draw the line and solve it that way. So 4, 9, or so 8, 8, 18, so on and so forth. And again, we're going to find that that's 54 tiles. Alrighty. Make a table and show the number of blue tiles and the number of yellow tiles in each figure. How many tiles will there be in a figure with 24 blue tiles? So this is blue versus yellow this time. So our X is blue, 1 blue, 2 yellow. 1 blue, 1, 2, 3, 4 yellow. Or 2 blue, rather. 1, 2, 3 blue, 1, 2, 3, 4, 5, 6 yellow. So 3, 6. 4, 8. If you catch on, the equation this time, it's doubled every time, right? Hopefully you caught that. So if I had 24 blue, I'm going to have 48 yellow. That's what we're looking for.